Hello, all. Welcome to my channel. I'm Raju Pujala. I'm very much happy to see that you are excited to learn machine learning models. So, this era is all about machine learning and artificial intelligence. It took me for a while, almost like 2 years, to understand how these ML models do work, how we can play our data by using ML models, and which channels to refer and which documents to go through it. But I will put everything in this playlist, and I can assure you that you can learn everything about the ML models within next 30 days. So I hope you are excited to go through all of my videos. In this playlist, I'm going to specifically talk about classification models. So there is something called classification and regression. We will focus on the classification. We will see all the different methods about the classification, like how the classification works, what to do, what not to do, how we can do that, how we can improve the accuracy, bad data, good data, and everything. Okay, and please stay with me through this whole series, and I promise you that you will learn and you will get like more knowledge about ML. So let's go ahead and let's start with our first video, which is the import sklearn libraries. So basically, they can call this sklearn or scikit-learn. Sk stands for scikit-learn libraries. So let's see all the libraries which are required for us to develop a ML model. So you might be also thinking like, oh, whether I should go with the TensorFlow or whether I go to PyTorch or whether should I go with the SK scikit-learn. So what I usually suggest and recommend, and what I learned is that if you learn the ML model using the scikit-learn, you will understand all the basic concepts, and then if you're dealing with the data, scikit-learn is like highly effective. But if you would like to deal with images, then you can either choose frameworks such as like TensorFlow and PyTorch, which I will cover after this scikit-learn playlist. Okay, let's deep dive into Google Chrome, and let's look for Colab. So you have to do like google.com. Let's go here. Let's search for Colab, and I'm taking a new notebook. So all of my videos are going to be the raw videos. I'm not going to add any artificial things or the graphics and everything. So whatever the time that it ideally takes for one person to go through that, I'm going to use that whole time, so that you will understand how much time it takes. And also what I'm expecting you guys is that whenever I'm practicing the code, I wanted you to open one more window, like my YouTube channel here, and one more window, and practice that. So by that, you can learn things more effectively, and practice is the key. You have to practice like again and again and again and again. That's it. Okay. So we will do ML classification, video number one, right? So I can zoom in a little bit for you guys. Okay. So I can name it like import libraries. Cool. So this is the first video. So now, so if you are watching this for the first time, I mean, if you have not used the Colab, so I'm going to use this Colab for forever. Everything is available over here. This is exactly a replica of Jupyter Notebook. You really don't have to install like many things for the Jupyter Notebook. Whereas a Colab, it's very easy. If you have not signed into Google account, so basically, once you go to the google.com, when you search for the Colab, so it might ask you to enter your email address and password, which is really safe. You can do that. I'm working at Google, and here at Google we use the Colab only most of the times. So believe me, this Colab is really helpful. So you will click on the connect button over here to connect. So it may take around like some time, and this is like freely available. So you can see that it is connecting right now. So once you click on this one, so Google company, they are giving you like a 12.7 GB of RAM for free, and a hard disk of 107. So basically, you don't have to pay anything. You just have to come here and you can directly use it. This is really helpful for you guys. If you're a student or a learner, you can easily learn everything over here. And here, if you click on this code, you will generate all these code cells. And if you want to write a text, you can click on the text. If you would like to delete, click on delete here. Okay. Okay, let's start with this one. Import import libraries. Okay, you can see what we are writing here, and this is how it looks like. So click on shift enter or shift return if you're using the MacBook. Okay, let's start with the most important libraries that we are going to cover in this whole playlist. Okay, so why I'm doing this one, because I wanted you to practice all these libraries so that in the middle of the code, whenever I import a library, you will not think like from where this library and how many libraries I have to practice. So what initially I thought when I'm learning the ML models, I'm like, oh my god, now I have to know, remember this ML model, this module, this library, or that library and everything. So if we can list down all the libraries in one go, so it would be very easy for you to recall it instantly whenever we are using that library again and again. So I'm going to use Matplotlib inline. This is for the graphs. So let's do like pandas, import pandas. So I mean, instead of writing pandas again and again, I'm using alias pd and import numpy as np. If in case if you are not familiar with the Python, you don't have to worry. I will explain about each and every libraries when I'm using it in the real time. But this is like I'm listing down all the whole modules here, so that you will take a note of this one. Okay, import. So this one plot lib.pyplot. This one we need to plot the graphs, and Seaborn is also one of the libraries which we can use to plot the graph. Import warnings. So whenever we are writing something, we will see like deprecated warnings and all. To eliminate that, I need this module. And to save the modules, I need a pickle, or else we have joblib as well. So I can write like import joblib, or within the joblib there are like many packages. If in case if I need something specific, I can do like from joblib I'm looking for import dump comma load. Okay, and then we may run multiple models in parallel, so I wanted that parallel package. Okay, and also I wanted the delayed. I will explain why we have to, when we have to use the parallel and delayed together. So click on this cell to see any warnings. Okay, there are no warnings. If there are any errors, you will see over here. For example, like here, print Rajiv, something like that. See what will happen here. See something like that. Okay, I'm deleting this one. I'm deleting this. Okay, in the next cell, I would like to import pipelines from sklearn dot pipeline, import pipeline, and make pipeline. So these pipelines are very much important, and these pipelines are not CI/CD pipelines. They are different. These pipelines really helps you to understand how your function works. Okay, and then we need PCA, which is principal component analysis. This is really helpful. I mean, when we are dealing with like huge number of data, high number of data, and then let's see, and let's take a look at these ones. Sklearn map. Okay, so let's do the choosing the right estimator. This one. So over here, you can see. Okay, this is how it start. If in case if we have more than 50 samples, yes. If in case no, get more data. At least we need like 50 samples. And predicting a category. So we're talking about the classification. So it's a category in sense like 0, 1, 2, or something like car color, red, blue, or some predicting something like that. And we have the label data, yes. And now if in case now you have to follow this one to understand what you're exactly looking for. So, and these are the different models: linear, SVC, SGD classifier, k neighbors, etc. So the most interesting libraries, the models in this classification is that ensembles, and then linear models, right? And whereas for the regression, all these are there. So right now, let's focus on the classifications. So I'm going back to this one. So let's like first let's write the regression. Okay, from sklearn dot linear model, import rich lasso. Oh, these are like awesome ones. Linear regression. And so basically this helps us to deal with outliers, imbalanced data sets, or like overtraining by using L1 and L2 regularizations. But if I say everything right now, I mean, you'll get confused. So I'm keeping it very simple. Ensemble, import random forest regressor. Now, do remember that Python is a case-sensitive language. So if you put something like R, it will throw an error. Okay, let's run this one. And let's also look for the classification models. Okay, so from sklearn import svm support vector mission, and from sklearn.svm import linear support vector classifier. And then let's see from sklearn.linear model. So these are for the regression, the continuous values. These for the discrete values. Import logistic regression. So this looks like a regression model, but actually this is a classification model. But I will explain you why this is a classification model, but not a regression model. But to be very honest with you guys, I really don't know why they kept the name as regression over here, but this is a classification model. And the curve of this, it looks like a sigmoid, FYI. From sklearn dot, let's look at the ensemble methods. So this ensemble method, this one and this one, oh my god, these are the best ones. When your data is non-linear and you have noise, you have to go with the ensemble methods, and these gives like high amount of accuracy, but it takes some time for the run. And random forest. If you wonder like how I'm writing all this, I mean basically I do practice almost like at least twice in a week, so that's how I remember everything. I mean practice is the key, guys. So from sklearn.tree, import decision tree classifier. So here in this one there are like multiple trees, and this is like only one tree. And don't worry, now we will talk about that. Cluster import k means, and from neighbors, oh my god, these is like awesome. K neighbors classifier. And also we have something important which is called neighbors. Import Gaussian NB. This is an awesome one. And also we have something to improve the accuracy. We have something called um, add a boost classifier. So to improve the accuracy, you can use this one. So this one ensemble technique like this one. Okay, these are the classification models that we are going to go through in this whole playlist. And now, so when you have the data, we need some encoders. For example, if you have categorical data, for example, then you need to convert the alphabets into the numeric, and for that we can use the pre-processing. So let's see the pre-processing. So for that we have from sklearn dot pre-processing, we have encoders. For example, label encoder, one hot encoder, ordinal encoder. We will go through each and everything. And we have for example, if you have values like 100, 200, we have to standardize this. For that, like something like 1, 0.9. So this is how it should be, like 0.81. So this is how it should be. So we can use scalars, which are like a standard scalar, and a min max scalar as well. And also let's take a look at transformers. Import column transformer, and make column. Both of them same only, but the syntaxes varies. You don't have to know both of them. I'm just mentioning it over here. And when we have the descriptions, data and all, we need some kind of natural language toolkit. So for that we have to use this one dot text import tf idf vectorizer. um, is transformer idf inverse document, I forgot, but let's take a look at it. And then the last one, if in case if you have blank values, this module is really helpful. Import simple imputer. Okay, so this is impute. And now let's also take a look at how we can evaluate ml model evaluations. So we have model selection. So we need some modules to split the data. So for example, if we have 100 records, you will use 80 records to train the model, and the rest 20 records to test the model how it is performing. And we have cross val scores. So this helps to understand whether you have imbalanced data set or normal one. And also, if to improve the accuracy, we need hyperparameter tuning, and for that we need these two: randomized search CV, grid search CV. Do remember that, guys? I mean, everyone, ladies and gentlemen. So Python is a case sensitive, and then let's look at the metrics. So once you train the model, you should understand whether how the ML model is working, right? For that, we need some metrics from sklearn.metrics import classification report. We can talk at least for 1 hour on this classification report, guys, and confusion matrix. So this is like awesome, and we need direct numbers like accuracy score, how to check the accuracy, precision score, recall score, and sorry, F1 score. And also we need we can also use ROC curve display. So this helps us to understand an ROC curve. We will plot ROC curve. ROC stands for root operating characteristic, receiver operating characteristics, and ROC AU score. So AUC is like area under the curve, and this is for the classification. This is for metrics for classification models. And now let's take a look at metrics for regression. Let's see, from sklearn.metrics import R2 score, mean absolute error, mean squared error, mean squared. Oh, these are like popular ones. Of course, we can't cover everything, but whatever I do use in my day-to-day life, I'm covering everything over here. And okay, and so we can also have two models from scientific Python, Scikit Python import sparse, comma, stats. So you can see whenever I run this one, if there is a green tick, which means that this library is already available, or else you have to import that library, which is again different task. So for natural, these are natural language toolkit NLTK. So import NLTK. Let's see whether this is like available or not. You can see it is running. If the package is too, if the package is like high memory, then basically it takes a little bit time. From nltk.corpus import stop words. This is also helpful. Stop words, basically it has like words like he, she, it, this, and all. So we can download this one and we can ignore those. And from nltk.stem.port import port stem. Okay. This is cool. And let's take a look at other useful memory libraries. Import OS, operating system, regular expression RE, import difflib, and import Python time zone to get the times, and import get pass to know like who is running this one, and import web browser as WB. So these are all the whole list of libraries that basically we are going to use in this whole playlist. I mean the regression, this one, and the regression, this one, I'm going to make a separate playlist. And so, I mean, if you remember, we are focusing on this classification, and in our other playlist, I'm going to focus on this one. And also we will talk about dimensionality reduction and the clustering as well. So I mean, just give yourself like 30 days, guys. I can assure you that after 30 days you will be like very much comfortable in terms of doing the machine learning models, and you can even go ahead and apply for the jobs. I can assure you on that. And if in case if you have any questions, or if you would like to reach out to me, feel free to reach out to me. I will pin my email address in the comment section, in the description section. Thank you for watching this video and support. If you like my content, please do subscribe, and please do share about my YouTube channel to others as well. Thank you, and have a good day.